Uh, Good evening. Today I'm going to talk about one of the delivery devices and tubings called the venturi masks, which is commonly used in the HDU patient in HDU. You can use it also in OPD. But I don't usually see it being used here in our settings. But I came across today one of the sets of venturi mask and tubing. This is what they call venturi mask and tubing. Okay, that is the venturi mask and tubing. Now you can see all these what they call fixed orifice devices. I will tell you the importance of having all this, and they are also color coded. Like this, for example, gives 50% FiO, and you open 10 liters from the oxygen source, whether being the oxygen concentrator or cylinder. So this will give you the exact amount of oxygen concentration or the percentage that you want to deliver to the patient. Normally we use 21% of the atmosphere when we are not sick, but in case of COPD means chronic obstructive pulmonary disease. Now the lungs are not functioning well, and our outward atmospheric oxygen saturation of 21% will not suffice. So you have to use other ways of delivering enough oxygen. So a guy came in and designed this, somebody called venturi, using a physics principle that was discovered by somebody also called Bernoulli, and I will tell you later a little bit how it works. What does that say? It's actually is a gas flow dealing with gases in motion, and we are usually applying these laws in our daily practices in anesthesia. And when you see in front of me here, look at this. Look at the colors. These are colors. They are called fixed orifice devices. Each of this color has a meaning, and it delivers a specific amount of FiO2 to the patient, and the question is why you need FiO2. Yeah, it's because supplemental oxygen alone is harmful, you need to mix it with atmospheric air. Now, this one, let me show you how to fix it. Okay, I have the one that I have dismantled here. This is the mask, and there are openings here which, when you are exhaling, carbon dioxide will come out from there, and this metal ring just to fit in the nose bridge. Okay, you have this corrugated tubing, right? You need to fix it here. You need to fix it like this with the pattern. Now you decide which FiO2 you want to give by using a venturi effect, because this are using the effect discovered by Venturi. So the Venturi effect, and Venturi also stole that idea from Bernoulli, which says when a gas flows through a narrow tube, the amount of the pressure within that tube will decrease, creating a vacuum, and that vacuum will entrain atmospheric air to mix with the supplemental oxygen that might be coming from the oxygen cylinder or oxygen concentrator. Now, the first thing I do is to fix the mask with this corrugated tube. Then I decided, I say I want to give my patient an FiO2 of, say, 50 liters. This one give 50 liters. So I fix it here. It will look like this now. The next thing I do, now you can see this tubing, they are the ones that will draw in the atmospheric air as when the oxygen is rushing in through that narrow orifice. So the speed of gas through that narrow orifice will let the atmospheric air get in. It is called entrained. It will be entrained in. So I want to give my patient an FiO2 of 50%, and I have to open the oxygen cylinder at the rate of 8 liters per minute. Now the next thing I do is this one. I have to put it on. Some people usually they ignore it, but it is the part of this system which you cannot ignore. It makes it work efficiently. You just fix it like that, and then the next thing is a delivery tube or cannula. And now this one, you put it like this. You have this patient side, and this will be to the oxygen source, right? Now it is ready. It is ready now, like that. And this one is going to give you, according to this color, using Venturi effect, it is going to give your patient an FiO2 of 50%. So, what does Bernoulli say? It says, supposing you have disconnected you connect it to the oxygen cylinder or anesthesia machine, and then you open the flow meters, 10 liters per minute. So oxygen that is coming from the anesthesia machine is a pure one. It will run fast. The speed will go faster, and the velocity of the air inside this narrow tubing will decrease the pressure or the volume inside this one, and that decrease will create a vacuum, meaning a space where there is no air. This is called the venturi effect. So as the gas flows down, and when it reaches here, what happens to the pressure? The pressure is low, and there is a vacuum which needs to be filled. So it is these openings that will draw in the air from the atmosphere into inside, because the one coming here is the pure supplemental oxygen, and it has to be mixed with air so that it gives you FiO2, and how much FiO2 will be determined by these fixed orifices created by venturi, either this, depending on the amount of FiO2 you want to give. So as gas comes with the speed here, the pressure decreases, and that decrease in pressure will pull in the atmospheric air, and the air from this side now will be mixed, will be supplemental plus atmospheric air, and that atmospheric air plus supplemental oxygen was determined by this device here. It will usually remain 50% at 10 liters. So your patient will receive 50 liters when you feed this. 50 FiO2, 50% FiO2 of oxygen that is mixed here. So the idea that the environmental air is pulled in to mix with supplemental oxygen is what we call the venturi effect. Anyway, the indications, I think you know, COPD, obstructive sleep apnea, even other causes you can use, nothing can prevent it. The same thing, the same principle of binaural also works with nasal cannulae, and that is what I want to share with you today. Next time, maybe I should talk about the CPAP and the BiPAP. Thank you.